So in this episode, we're going to talk about experiment for Form 4 chapter heat. So in heat, what are the experiments? So of course, we are going to talk about specific heat capacity. Now, if you see your experiment, Amali, has thermometer, has water, has a Bunsen burner, or even they might actually give you something what we call the immersion heater. So immersion heater is actually a rod that you will add into the water, you book up the electricity, then it will start to heat up the air. So those are the things that you know that it is going to be a heat, Amali. Now, in this experiment later, I will agak-agak tell you how to write out a good procedure, even though if you forget to memorize the procedure. So now, let's start by looking at the title first. So in every experiment, guys, remember, you need to always read the relationship, investigate the relationship between who and who. So in this case, this is your time versus the change in temperature. Okay, so the triangle actually means change in theta, means temperature, change in temperature. So time change, so maybe a few minutes, then your temperature will either increase or decrease. So remember, there is also many type of variations. Maybe they will come out mass against change in temperature, means that you use less water, then you increase the mass of the water, then you see the change in temperature. So guys, remember, read your Amali questions properly. Okay, so once you're done with this, okay, so we see a Bunsen burner, most likely is going to be you heat up the water, and then after every specific time intervals, you take the reading. So let's start by looking at the questions first. So don't worry about doing the Amali. So look at the question first. Okay, so manipulated variable is what? So usually, the relationship is going to be both your manipulated and responding, or ataupun you can even see the graph. Graph, 99% of the graph is always responding variable against manipulated variable. So oleh itu, they already tell you against T, this. So what is your manipulated variable? So therefore, my answer will be the heating time, comma T. You are required to write the alphabet as well. Then what about this one? The change in temperature of the water. So triangle theta. Okay, so remember temperature, I write TM, but you have to write temperature of water. So then finally, what is about our fixed variable? So in physics, the rule is like this. When you write variables, variable must be things that has value, must be measurable. For example, can I write type of liquid used? So type of liquid got number or not? Can you say the type of liquid is 10, 20? Cannot. So type of liquid is not an acceptable variable. But density of liquid can. Mass of liquid can. Specific heat capacity of liquid also can. So if you say the type of liquid used, make sure to be more specific. So to keep it simple here, I will just say mass of water used. Why? Because fixed variable is the thing that you allow it to remain the same. Okay, so mass of water used, or you have another choice, which is the specific heat capacity of liquid used. Means that you cannot change the liquid. If you start your experiment with water, the whole entire experiment, you must use water, 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 water. Okay, tabulate your data here. Okay, so this is once you go to tabulate, this is where your practical is lah. Okay, so this is where the Amali you have to do. Now guys, is it possible that your data and your friend data tak sama? Okay, I think it's very normal, right? Okay, why? Because if you think about it, it's like karangan. Okay, everybody got different feeling, everybody got different story, everybody got different style. So if you do Amali, it's just like karangan. Nobody will have exactly same data unless you tipu, unless you cheat in your exam. So if your answer is a bit different, never mind guys, okay? But most importantly, follow the instruction. Like for example, they call you to draw three things, tabulate the value for 1, 2, and 3. So make sure that your jadwal got 1, 2, and three columns, all right? Make sure you fix the decimal, all right? So usually for thermometer, you can choose not to write the 0. Okay, kenapa why because thermometer punya sensitivity is only up to, let's say 37 degrees Celsius. 38 degrees Celsius. So the change in temperature is only 1 degree Celsius. So if you don't write decimal place, it's okay. Because the smallest thing that you can measure on your thermometer is 1 degree Celsius. So you can write 7, 13, 20, 27, 33 pun boleh lah. Okay Okay, next. So once we are done with this jadwal, so this table is basically your experiment. So after 2 minutes, you measure the temperature, then 4 minutes, 6 minutes, 8 minutes, and 10 minutes. Then why is there a change in temperature? Because maybe before you do this experiment, you have to measure the initial temperature so that you can minus to find your change in temperature. So from what I see here, maybe the initial temperature is 29 degrees Celsius. Okay, but guys, don't hafal my 29. What if that day when you do your experiment very hot, right? Then the water come out from the tap 32 degrees Celsius. Then you take 32 degrees Celsius as your initial temperature lah. Okay, not can. So don't memorize my data, yeah. Okay, so once you're done with this thing, okay, on the graph paper provided, plot a graph. So we're gonna go and plot a graph. So your graph, y-axis, x-axis. So this is your change in temperature, degrees Celsius. Make sure you write the symbol with the unit. Make sure you write the symbol with the unit as well. Okay, so T minutes, theta degrees Celsius. Okay, you can use slash, you can use comma. Sometimes, right, this is very dependent on your school teacher, because the person's gonna mark your paper is your school teacher. All right. Okay, then after that, so you already have your axis already. So the most common mistake is people don't write 0 on the left bottom corner. Your teacher take this very seriously. Okay, then after that, let's talk about the scale. Remember, your scale has to be consistent. Let's say 5, 10, 15, 20, 25. Some people, right, they will try to lompat scale. Let me show you. They might say, "Aya, since we don't need 20 degrees Celsius, why don't we start at 30 so that we can get 31, 32, 33, 34. So it will be more accurate." Okay, but the problem here is sini is 1, but sini is 30. So you realize that your scale is not consistent. So this is in physics graph, a very big no, tak boleh. Okay, cannot. So we do not practice that. We always have to go for standard scale. So every scale, if the first scale is 5, then it will be 5, 5, 5, 5, 5, 5, 5. Okay. Then when we do graph, okay, so your graph might be something, your points might be slightly scattered. Let's just say this way lah. So you're gonna draw your graph of best fit, right? Correct. Okay. So is this considered a graph of best fit? Yes. Why? Because you got 2 points below, you got 2 points above, you divide the points quite equally, and you pass through at least one of the point. Okay, so this is your graph of best fit. But some people will waste so much time try to agak-agak and check their graph of best fit. Guys, never mind. The line is just 1 mark. Don't stress yourself so emotionally sad because your line sengit by that one little tiny bit. Never mind, guys. Just let it slide, okay? So you're gonna draw this out. You're gonna write this. You're just gonna like draw this line. Make sure it touches the y-axis, not 0 or y-axis, because some graphs are not meant to be from 0 lah. Okay, let's say for example, mungkin lah your graph macam ini. Your points are all flying in the sky. Are you gonna draw like that as your graph of best fit? Of course, this one salah, right? So this one, most likely your graph of best fit will be something like this. Okay, so this one never start from 0, but never mind. But you still have to touch the y-axis. Some people ask me, "Teacher, how to know whether my graph got start from 0 or not?" So when you try to draw the graph of best fit, you see your graph of best fit very cacat one. Like macam mana. Okay, so let me show you Okay, like that. Will you pass up this line for your exams? You think that there's no problem? You see this get so big? Yeah, so then you probably know that there is a problem lah. Okay, Ken, alright. So definitely your line will be perfect one lah. Okay, but it's Amali. Okay, so your teacher will accept the imperfections. So, okay, once you plot the graph already, okay, you want to write the title, boleh. 0 check, axis check, line check, points check, scale check, then you should be fine. Okay, what's next? It will be the relationship. Okay, so relationship, we got y is directly proportional to x, which directly proportional means that your line is a straight line, start from 0. Number 2, your y increases linearly with x. Yang this one, the line is like this one. It goes up like that one. So it didn't start from 0 one. Okay, we got the third one, which is called special sikit, like that one, which goes all the way down. Okay, maybe y'all can comment and tell me what is the relationship of this line. Okay, so the answer will be at the comment section. Okay, so the perbezaan is 0, no 0. This one is going down, but the going down is a straight line. Okay, and then number 4, okay, is the curve punya. Okay, guys. For the curve punya, right? Okay, so far I've been teaching physics for 16 to 17 years. In 16, 17 years, right? Only one time come out curve lah. So I don't think your Amali will come out curve lah. You don't have to be worried lah. Alright? I'm quite certain it won't be a curve. Okay, so since we draw this graph, and we realize that it starts from kosong, so what we're gonna do next is we will talk about the relationship. So we will say that your theta is directly proportional to t. Okay, so this is directly proportional to t. So make sure that you state the alphabet. Don't just write directly proportional, okay, guys. Okay, so now we reach the last 2 questions, which is people always throw marks one. Okay, guys, gradient got unit or no unit? The answer is yes, gradient must have unit. Tapi can you memorize the unit? No, because it depends on what kind of graph you have lah. Okay, so we have to calculate. Now we check this out first. Okay, before even I start calculating, I already know what the unit will be. Why? Okay, because I checked already. My graph is theta degrees Celsius against minute. When we calculate gradient, we will take y-axis over x-axis. So we will take degrees Celsius, we're going to divide this by minute. Oleh itu, our answer will become theta degrees Celsius per minute. So that will be my unit for my gradient. Okay, not? So now, the only part is doing the calculation of the gradient. So when we do gradient calculation, we always need to do things like your triangle. So let's say you take suka hati lah, you take this point, and then you draw your dotted line all the way down, and then the smart people will take origin lah, guys. Why? Because origin is 0 coordinate. So this is your triangle. You can write out this coordinate, okay? Then after that, this is your triangle, right? Okay, the 90-degree triangle, right? Dotted line, So now we're gonna do this together. Okay, so our gradient will be something y2 minus y1, x2 minus x1. Since I take origin as my answer, I can take this, and then I can take, let's say, 10 minutes minus 0. So I'll get 3.3 degrees Celsius per minute. Okay, guys. Teacher, why my gradient different from my friend punya? Of course, because you all use different set of data. Your data different. The way you do experiment, maybe your friend sit under the fan. Maybe you sit near the window. So there are many things that out of control one, So if your answer differ by like 0.1, is it a big deal? I don't think so lah. So ultimately, this is 3.3 degrees Celsius per minute. Then sometimes they will say, please express your answer in terms of SI unit. So what is the problem here? Minute is not SI unit. So we have to change this to degrees Celsius per second. Okay. Per minute means every 1 minute, your thing reduces by 3.3. 1 minute reduce 3.3. So 1 second reduced by how much? So if minute you want to go to seconds, you want to make it smaller, right? You're going to divide by 60 because you want to break from 1 minute, you want to make 1 second. So means you have to reduce it by 60 times to 1 second. So you divide by 60 lah. So then you will have your answer, degrees Celsius per second. So therefore, this is your the answer. Alright. And then after that, of course, if they never say change to SI unit, you have a pilihan. You can use degrees Celsius, also you can use degrees Celsius per minute, you can use degrees Celsius per second. Completely up to you. Alright. Okay. Then we go to the next part. What will happen to the gradient in E when this experiment is carried out using less volume of water? Okay, now don't have to memorize, don't have to memorize, don't have to think so much. Just ask yourself, if you use less volume of water, your water will heat up faster or slower? Okay, you masak. Sometimes when you drink soup, big bowl of soup, you will scoop the soup out to make it cold. Put to smaller bowl so that it cools down faster. So if you use less volume of water, the temperature change will be faster. So obviously this thing will heat up faster. So if it heats up faster, Meaning to say, okay, before I write down my answer, I think first, degrees Celsius per minute. Okay, so ini my original graph. So if it heats up faster, meaning to say that the temperature will go higher, right? So the line will go higher, right? So means that my gradient macam mana? So obviously, my gradient of graph will increase. So the answer here is that the gradient of the graph will increase. Why? Because it will heat up faster. So that's it. All right. So I'm more concerned about the belakang question. Okay. Sometimes they might even ask you, if let's say I change this to oil, meaning to say that currently I'm using water, right? Kalau I tukar this to oil, how will the graph change? Okay. So now you have to ask yourself again, oil heat up faster or slower? Obviously, oil will heat up faster, right? So therefore, basically, it also heats up faster. So your answer is the same lah. Your gradient of your graph will increase. So as the gradient of your graph increases, as the gradient of the graph go up, what will happen di sini adalah, if they call you to explain why, you can say because oil has lower specific heat capacity. So it uses lesser energy to heat up, so it will heat up faster. So this is actually a very good answer. Okay, so this is what the quality of answers that we want for a very typical Amali question. Okay, what about special case? Okay, guys, and what about procedure? Okay, now for the full procedure, I will write it in the comment section. Okay, and I want you to learn how to copy this procedure. Okay, so usually in procedures, since we know what apparatus will come out, there are a few pointers that I want you to check. Okay, make sure you mention your manipulated variable, your responding variable, and you repeat your experiment by total of 4 times. You will have one manipulated variable here, let's say 2 minutes already. Later on, you will repeat with 4 minutes, 6 minutes, 8 minutes, and 10 minutes, supaya you get 1 set of data, 2 set, 3 set, 4 set, and 5 set of data. So they will check these kind of things, all right? Okay, and then when you write procedure, okay, because now is what if you don't know, right? Or ataupun, instead of Bunsen burner, they change another way to heat up the water. Let's say they use immersion heater. Then you have to tukar lah. Instead of you say, you start the Bunsen burner, you have to say you switch on the immersion heater. Okay, and then remember, because the manipulated variable is your heating time taken, you have to tell me when do you start measuring. For example, the stopwatch is started, okay, of course, and your apparatus as well. You have to be more clear, like the stopwatch is started when the Bunsen burner is being turned on. Okay, then your responding variable is your change in temperature. So if you have to tell me change in temperature, do you need to tell me that I have to take my change in temperature is actually my final temperature minus my initial? Do I need to write this equation inside? Do I need to write this formula inside? The answer is yes, we need to write this equation inside. Yes. Okay, because that's how you find the change in temperature. So your teacher will look at all these, what's your apparatus, how do you measure your manipulated variable, then after that, how you measure your responding variable and how you repeat. So biasanya procedure is like 2 to 3 marks only. So focus more on the variables in the procedure and you repeat the data. There are certain things which students very stress on, okay, like for example, so we start with, let's say, 400 cm cube of water in the beaker in this experiment. Let's say, okay, maybe your experiment tell you to start with 300, or maybe your friend say 500. Guys, it doesn't matter, because when they don't give you the procedure, you suka hati you want to start with 400, 500. So therefore, it doesn't matter. Okay, so it doesn't matter. All right, so let's say you set lah. Okay, let's say we just use 400 lah, because 500 maybe is too much water. Okay, then we just use 400. If you use 300, I think it's reasonable also. Okay, so therefore procedure is just this. Okay, what about certain things that are more complicated? Okay, now one of the very interesting experiment that I want to share with you all is this one. So this one is, instead of we go from low temperature, we heat up to high temperature. Wow, this one special, guys. Terbalik one. We start with high temperature, go to low temperature, you know. So this one, the heat from the hot water will be released to the surroundings to investigate. Okay, so now you're trying to find the release. So it starts at 90 degrees Celsius. Okay, let's say for example, I heat up to 90 degrees Celsius, and then for every 1 minute, so this is the time taken. So at 1 minute, it will reduce to 84, then it will slowly become 78, it will become 72. So I measure the temperature drop. Okay, so from 90 to 84, drop 6 degrees Celsius. 90 to 78, drop 12 degrees Celsius. 90 to 72, drop 18 degrees Celsius. So I measure the temperature drop. Okay, so this is going to be the change in temperature. Okay, but why I want to discuss this thing so special is because, remember guys, change in temperature no negative one. So when temperature drop, I think some people will go and draw negative graph. No guys, okay, people ask me this, teacher, if this is a temperature decrease, because like what I said just now, the first experiment is low to high, now is high to low, right? So if high to low means that, teacher, my temperature will drop, so my graph will be like this. No, bukan. Because you are plotting change in temperature. The longer the time go, the temperature will change, right? So your graph will still be like this. It will still be a going up graph. Most likely, it will still be a directly proportional graph. Okay? Why don't you draw and you tell me how will your graph going to be different? Let's say for example macam ini. So how would your graph be different? Alright, so try to sketch it out, guys. The thing that if the best thing that you can do is try to go and study a bit on specific heat capacity, rather than you say, "Aya, Amali don't know what to study. I already memorized the procedure." Go study some specific heat capacity knowledge. So maybe they even ask you, what's the definition of specific heat capacity? Very hard to say, kan? Okay, so now, one most interesting thing here is, what is the operational definition of temperature? Okay, usually operational definition means in physics is how to measure temperature. Okay, so I give you, for example, certain things. Okay, let's say maybe they ask the ticker tape, how to measure the distance traveled by the trolley. So we can say, we measure the distance between the dots by using a meter rule. So you see, okay, they ask you how you measure distance traveled by the trolley. So how to know the trolley travel how much? You measure the distance between the dot because this distance, like let's say 10 cm, is the trolley tarik 10 cm, means your trolley move 10 cm. Okay, so how you measure temperature? So we just have to say temperature is measured by taking the reading on thermometer. So this is the paling senang one. How to measure temperature in this world, right? In our syllabus, right? The only way that we can measure temperature is by using thermometer lah. Itu saja lah. Okay So we're gonna use on thermometer. Okay, then what is another one more thing that is very difficult? Usually, is when they ask you this kind of what will happen. Okay, so if you wrap with a felt cloth. So sometimes in your Amali, right, maybe they will give you like cloth, okay? They give you a kain, they'll give you a cloth, or they give you like a tissue paper. Okay, guys, this one are not for you to wipe your sweat, This one is for you to mainly wrap this thing out so that you can reduce the heat loss. Okay, now so you must think about it lah. Okay, you reduce the heat loss to surroundings. So how will it affect your experiment? So this one also you have to faham. If you heat up your experiment, okay, if you go from low temperature to high temperature, means that if you reduce heat loss, means that it will be faster, right? Correct? It will be faster to reach high temperature. Why? Because you trap the heat inside. So when you do this experiment, you won't lose heat to surroundings, so it will be faster. But For this one, your rate of change in temperature, because this is experiment number 2, this one is you heat loss to surrounding. So for this one, if you go from high to low, meaning to say that your heat loss will be slower. Your heat loss will be slower. Why? Because you reduce the heat loss to surrounding. So therefore, what makes this experiment slightly more tricky is you have to think whether is it your experiment is a heating up experiment or a cooling down experiment. Okay, so food for thought lah, guys. Just need to think about it. Okay, don't wet the cloth, don't wet the tissue. Okay, because some students I will think they're very smart. They're like, the tissue cannot stick on the beaker. So what do? We add water to the tissue. Then I use the tissue to stick on the wall. Cannot. Because if you put water to the tissue and you stick it to the beaker, the water on the tissue will absorb the heat faster. So that is actually a very big no-no. So you want your cloth to be dry and you also want your tissue to be dry. Okay? So now if you make this mistake means you didn't watch until the end of the video. So don't wet your cloth, don't wet the tissue. Alright, just wrap it. Okay? Most importantly, also need to put the cloth and the tissue on the ground so that it doesn't touch the wall of the table. So that's the best place to put your tissue also. Okay, because usually the heat loss is through the table. It will be faster. The heat loss through the table will be faster. Okay, so ultimately this is it. The answers are provided at the back. So try to download or probably go to YouTube and you can download this file and write it sekali. Okay, so if you got any problems, feel free to drop a comment. I'll reply the comment when I can. Okay, so for this episode, we will sampai sini sahaja. See you guys in the next episode. Thank you, everyone.